Hello everyone. In this video, I'm going to talk about vector equations of lines. If this is your first time here, and if you want to improve your math skills, make sure you subscribe my channel by hitting the subscribe button below so that you won't miss any videos later, because in my following video, I am going to talk about vector equations of planes. If you find that this video is useful, please share to your friends, to your students, or to anybody who need this. So, let's start the lesson right now. In this video, I'm going to talk about vector equations of lines. Generally, the vector equation of a straight line is r equals a plus lambda b. If we want to write the vector equation, we must have a and b. A is the position vector of a point where the straight line passes through. B is the direction vector which is parallel to the straight line. So for example, we have a straight line L1, and L1 passes through a point A, and it is given that the coordinates of point A are 3, 1, and 2. From the coordinate, so we know that the position vector of point A is 3i plus j plus 2k, because position vector and coordinates are equivalent. Since A is the position vector of the point where the straight line passes through, so therefore A is equal to 3i plus j plus 2k. As for B, B is the direction vector which is parallel to the straight line. So let's say it is given that B is equal to I plus 2j minus k. Since we have A and B, so now we can write the vector equation of this straight line L1, that is r equals 3i plus j plus 2k plus lambda times I plus 2j minus k. So some of you may ask, then how about r and lambda? R is the position vector of any point that is on the straight line. So let's say I have a point on the straight line that is r, and the coordinates of point r are unknown, so I label x and y and z. So let's say if I want to find the coordinate of this point r, then I must refer back to point A. Then I have to determine the distance from A to r. To determine the distance from A to r, we can use the vector b as the unit vector, where from A to r, we need 1, 2, and 3 unit of vector b. So in order to find the position vector of the point r, we need 3 unit of vector b. So means now the lambda is equal to positive 3. So now when I simplify, then I get 6i plus 7j minus k. So this is the position vector of the point r. So from the position vector, now I can get the coordinates of point r. They are 6, 7, and -1. Here, let's say I have another point r, where r is on the left hand side of A. If I want to find the coordinates of point r, same thing, I have to refer back to point A. I have to determine the distance from A to r. To do this, I can use the vector b as the unit vector, where I find that the distance from A to R, the distance is equivalent to 2 units of b, but the direction is opposite direction compared with the vector b. So therefore here lambda is equal to negative 2. 2 because 2 unit of b. Negative because the direction is opposite. So when I simplify here, I will get I minus 3j plus 4k. So this is the position of the point R. So from the position vector of point R, now I can get the coordinates of point R. They are 1, negative 3, and 4. So generally when writing the vector equation of a straight line, we need to know the position vector of the point on the straight line and the direction vector of the straight line. The lambda, we leave it in unknown, so that the vector equation represent all the points on the straight line. So when writing vector equation of a straight line, other than using ij form, we can also use column vector form. That is 3 is x, 1 is y, 2 is z as the position vector of the point. For direction vector, 1, 2, and negative 1. So this is the column vector form of vector equation. Now when answering the question about finding the vector equations, there are two possibilities. One, the question will give us a fixed point and a specified direction, or maybe the question will give us two fixed points without a specified direction. So now let's look into it one by one. Now let's look at this question. Find a vector equation for each of the following lines. So for the first line, L1, L1 passes through the point A and parallel to the vector B. Since the point and the directions are given, so we can straight away sub into the formula where A is the position vector of the point A, that is I minus j plus 2k, and the b is the direction vector 3i plus k. So this is the equation of L1. Then for L2, L2 passes through the point B and parallel to the line. So here the position vector of the point, it is given. Now since the straight line is parallel to another straight line, where from the equation of another straight line, we know that the direction is this one. So since these two lines are parallel, so means we can use the same direction vector. So therefore, the vector equation of L2 is the position vector of point B and the direction vector which is parallel to the straight line. Here, for the lambda, we don't use lambda because lambda it is already used here. So for the different straight line, we try to use the different symbol. So I just use a mu to represent the unknown here. You can also use other alphabet to represent the unknown of lambda. Now for line L3. L3 passes through the point C and parallel to x-axis. We know that the unit vector for x-axis is I, and at x-axis the values of y and z are equal to 0. So therefore the direction vector for the straight line is I. So when we sub into the formula, so this is the vector equation for the straight line. Then for straight line L4, L4 passes through the point D and parallel to y-axis. So unit vector for y-axis is j, and at y-axis, x and z are equal to 0. So the direction vector is j. So when we sub into the formula, this is the position vector of the point, this is the direction vector, so this is the vector equation of line L4. So as for line L5, L5 passes through the point E and parallel to z-axis. For the unit vector z-axis, it is k. At z-axis, y and x are equal to 0. So means the direction is k. So when we sub into the formula, the vector equation for line L5 is this one. Now for line L6. L6 passes through the point C and perpendicular to the plane with the vector equation of the plane given here. So for L6 passes through a point C and perpendicular to a plane, from the vector equation of the plane, we can see the normal vector. Normal vector is a vector with the direction it is perpendicular to the plane. Since the straight line is also perpendicular to the plane, so means the normal vector is parallel to the straight line. So means we can use the normal vector to be the direction vector of the straight line. So in this question, the vector equation of the plane is given here, and from here we can see that the normal vector is 2i minus j plus 3k. So we can use this normal vector as the direction vector of the straight line. So now we can write the equation of the straight line, that is, this is the position vector of point C, this is the direction vector of the straight line that we take from the normal vector of the plane. As for the vector equation of the plane, we will discuss in the following video. So don't forget to subscribe so that you won't miss the video later on. Now we look at line L7. L7 passes through the point C and parallel to the xy plane. Now we look at the xy plane. Xy plane, we can see that the value of z is always equal to 0. So means the direction for xy plane is I plus j. So when we substitute the position vector of C and the direction vector of the xy plane, now this is the equation of the line L7. Then we continue to L8. L8 passes through the point E and parallel to xz plane. So when xz plane, the value of y is always equal to 0. So means the direction for xz plane is I and k. So when we sub the position vector of point and the direction vector, then this is the equation vector for the line L8. Then as for line L9, L9 passes through the point E and parallel to YZ plane. For YZ plane, the value of x is always equal to 0. So means the direction for YZ plane is j plus k. So when we substitute the direction and the position vector of the point, then this is the vector equation of the line. Now, when finding vector equation of a straight line, sometimes we are not given one fixed point and one direction vector. Sometimes we are given only two fixed points. So, for example, let's look at this question. Find a vector equation of the line passes through the points A and point B. So, we know that when writing vector equation of a straight line, we need a fixed point where the straight line passes through. So now we have 2 points. So we can use either point A or point B. Then after that, we also need a direction vector which is parallel to the straight line. But from the question, we don't have such direction vector. But we can calculate, that is, we can use point A and point B to calculate the direction vector of A to B. So from the coordinate of point A, so we know that the position vector of A is 5, 2, 6. From the coordinate of point B, and also we know that the position vector of point B is negative 3, 6, 2. Then for direction vector AB, it is equal to the vector AO plus OB. For the vector AO, we can take from OA, but the only thing is it is the opposite direction. So all the numbers here, we have to change the sign, that is from positive to negative, from negative to positive. So means AO, it is negative 5, negative 2, and negative 6. So OB we can take from here. Then when we simplify, we will get the vector AB is negative 8, 4, and negative 4. Now you can use this one as the direction vector. But most of the time, when we write vector equation, the direction vector is in the simplest form. So when we look at here, this direction vector, it is not in the simplest form. Means we can factorize 4 out from the vector to get the simplest direction vector, that is negative 2, 1, and negative 4. Or we can also factorize negative 4. So that the direction vector is 2, negative 1, and 1. When finding the direction vector, instead of AB, I can also use BA, where BA it is equal to BO plus OA. Then for BO, we can take from OB. Then the only thing is we must change the positive to negative, negative to positive, because the direction is opposite. So means BO is 3, negative 6, and negative 2. OA we can take from here. Then when we simplify, we will get 8, negative 4, and 4. Same thing, if you want to change to the simplest form, we can factorize 4 out, becomes 2, negative 1, and 1 as the simplest direction vector. Or you can factorize negative 4 in order to get the direction vector negative 2, 1, and negative 1. Now we have 2 position vector and 2 direction vector. So to write the vector equation of the line, so means we have more than one answer. So you can either take the position vector OA with the direction vector 2, negative 1, and 1 to get the vector equation. Or you can also use the position vector OA and the direction vector negative 2, 1, and negative 1 as the direction vector to get a vector equation. Or maybe you can use OB as the position vector and the direction vector you use 2, negative 1, and 1. Or you can use OB as the position vector and you use the direction vector negative 2, 1, and negative 1. So means we have more than one answer for the vector equation. Now to write the equation of a straight line under 3D, we can use vector equation. Other than vector equation, we can also use Cartesian equation to express the equation of a straight line. So when we look at here, the Cartesian equation of a line on 2D Cartesian plane, the equation is y equals mx plus c. But what is the Cartesian equation of a line under 3D Cartesian space? Now let's look at this example. Express the vector equation of the line given here in Cartesian form. So first thing we need to do is we try to rewrite the vector equation by using vector form. So this is the position vector and this is the direction vector. Then from the vector, we take out all the elements from the first row. Then we get x equals 3 minus 4 lambda. Then from second row, we get y equals 1 plus lambda. Then from third row, we get z equals negative 4 minus lambda. After that, when we look at here, this is what we call as parametric equation of the straight line. Now, to get the Cartesian form of the equation, we need to rearrange each of the equation here such that lambda becomes the subject. So when we want to find lambda becomes the subject, first we shift the constant to the left hand side, becomes x minus 3. Then only we shift the negative 4, becomes x minus 3 over negative 4. Here we just leave the denominator as negative 4 and make sure x is in positive. Then after that, for the second row, when we change lambda as the subject, we shift the negative into left, so becomes y minus 1. For z, to change lambda as subject, first we shift negative 4 to the left, becomes z plus 4. Then only we shift the negative 1, so becomes z plus 4 over negative 1. Then we just leave the denominator negative 1 here. Then after that, we can combine all these three equations into one. That is x minus 3 over negative 4 is equal to y negative 1 and also equal to z plus 4 over negative 1. So this is the Cartesian equation of the straight line. Now let's look at another example. Express the vector equation of the line given here in Cartesian form. So first step, we need to change the vector equation in vector form. So this is the position vector, this is the direction vector. Then we take out each of the element from each row. So first row, x is equal to 3 and lambda is equal to 0. Then second row, y is equal to lambda. Then third row, z is equal to negative 4 minus lambda. Then when we look at here, we need to change the equation of z such that lambda is the subject. So to do this, first we shift the negative 4. So to get z plus 4, then shift the negative 1. So lambda is equal to z plus 4 over negative 1. Then after that, now we want to combine. We find that x has no lambda, means lambda is equal to 0. Then only y and z has got lambda. So means we can combine y with z, and x equals 3, we write it here. X equals 3, then comma, then we combine the lambda. Y is equal to z plus 4 over negative 1. So this is the Cartesian equation of the straight line. Next example, express the vector equation of the line given here in Cartesian form. So first, we write in column vector form. This is the position vector. This is the direction vector. Then from first row, x is equal to 1. From second row, y is equal to negative 2 plus lambda. Third row, z is equal to 3. Now to write the Cartesian form, we find that only y has got lambda. So in this case, we are not able to combine any row. So therefore, the Cartesian equation of this straight line is x equals 1 and z equals 3. Now for the Cartesian equation, we can change back into vector equation by using the reverse process. So first thing what you need to do is we separate x, y, z by using the lambda as subject. Then from each one, we need to rearrange such that X becomes the subject, Y becomes the subject, and Z becomes the subject. When I do the arrangement, I must make sure all the constant is in front, then followed by lambda. Because from here, I can take the vector equation. X, Y, Z is the position vector of any point. Then all the constant, that is the position vector of the fixed point. Then all the coefficient of the lambda, that is the direction of the straight line. Now I get the vector equation of the straight line. Then next, if I want to change the Cartesian equation given here into vector equation, same thing, I need to separate x, y, and z by using lambda. So lambda equals x plus 1. Then I put in the y here because I need to follow the sequence x, y, z. Then followed by z here. Now for the first one, I change to x equals -1 plus lambda. Now for y equals 0, actually it is equal to y equals 0 plus 0 lambda. Then z equals 3 plus 2 lambda. Then I must make sure that all the constants are in front, then followed by the lambda. Then from here, I can write the vector equation. So x, y, z is the position vector of any point on the straight line. Then from the constant here, I will get the position vector of the fixed point. And from the coefficient of the lambda, I will get the direction vector of the straight line. So now I'll get the vector equation of the straight line. So that's all for now. Do you understand what you learned today? If you have any question, let me know in Teacher Ailin Math Group. If you find that this video is useful, hit the like button. Don't forget to subscribe my channel. Thank you so much for watching. I hope you keep on learning and keep on watching my videos, and I hope to see you soon. Bye.